Okay, welcome back to Mr. Hassan's Maths channel. We are now on the last question, which was question number 10 of the P2 June 2019 International A-Level paper. This was actually the first paper that was set for this new syllabus. Anyway, this question number 10 tells us that figure 1 shows a sketch of part of the curve C with equation y equals f of x, where tells us that f of x is equal to 36 over x squared plus 2x minus 13, and it tells us here, very importantly, that x cannot be equal to 0. X is greater than 0. X is greater than 0. Okay, we know in this equation x can't be 0 because it will be undefined, but they tell us in this question something very important: x is greater than 0. So don't ignore these things, and you'll see in a minute why. It says, using calculus, find the range of values of x for which f of x is decreasing. Now, when it says using calculus, basically it means, differentiating. Basically, that's what it means, using differentiation. That's what it means. Now, so the range of values of x for which a function is increasing are the range of values of x for which that function has a positive gradient, because a function increases when its gradient is positive, and it decreases when its gradient is negative. And we can see this function is decreasing until the point at which it turns, where the gradient becomes 0 at this particular point. At this point the gradient is 0, at the point where it turns. Okay. And then the gradient starts to become positive again. So we can say that f of x is decreasing in this part when the gradient of f of x is less than 0, and it's increasing when the gradient of f of x is greater than 0. Some people will write equal sign with these as well. Okay, but I don't like to do that, and the answer is perfectly fine if you write it like this. In fact, that's the main answer given in the mark scheme, where it doesn't have the equal sign, but they all accept greater than or equal to. But the confusing thing is that in your P2 books, all the answers are with the equal sign, where it's acceptable, but it's not really something which we normally write. We normally write it because it's increasing when the gradient is positive. That's like the more kind of like intuitive way of thinking about it. When the gradient is greater than 0, it's increasing. When the gradient is equal to 0, it's like kind of not really increasing or decreasing. However, it's acceptable to have the equal sign in both of these cases, whether it's increasing or decreasing. So if you did that, there's no problem. Now, it says find the range of values of x for which f of x is increasing. So as we mentioned, the gradient is what determines whether it's increasing or decreasing. Now, if the gradient is positive, it's increasing. So we have to basically here, we can say that it's increasing. It's increasing when the differential of fx is greater than 0. Okay, so first thing first, that means we have to differentiate this function. So let's first get it ready to be differentiated, because it's not quite ready yet, because this term, you've got the x term in the denominator. The x terms must be in the numerator. So this must be 36 x to the power of negative 2 plus 2x minus 13. Now it's ready to be differentiated. So f dash x means the gradient of the function f of x is equal to, now when we differentiate, you first multiply by the power. So it's negative 2 times 36, which is negative 72, and then you take 1 away from the power. So you're going to have x to the power of negative 1. Okay, sorry, negative 3. That's adding 1 to the power. Take 1 from the power, you have negative 2 minus 1 is negative 3. And then you differentiate 2x, it becomes 2. Why does it become 2? Because 2x is actually 2x to the power of 1. Multiply by the power, you get 2, and then you take 1 from the power, so you have 2x to the power of 0. Now x to the power of 0 is equal to 1, so you don't have to write it. And minus 13 is a constant, it disappears, and you can kind of think of that as, this is minus 13x to the power of 0. Okay, like that's, x to the power of 0 is equal to 1. So it's kind of equivalent to this in terms of x, because we're differentiating with respect to x. So you're going to multiply by the power, well, the whole thing becomes 0. So you don't have to write it down. Okay, so now, as we said, it's increasing when this is greater than 0. So when we solve the inequality, minus 72, let me just write this with the x now in the denominator, over x cubed plus 2 is greater than 0. When we solve this inequality, we'll find the range of values of x for which this is an increasing function. If the question said find when it's decreasing, then we'll just put less than 0 here, that's all. Okay, so now, to solve this inequality, what I'm going to do is I'm going to add 72 over x cubed to both sides, because I want to keep the term which I'm trying to solve for positive. That always makes life easier when you've got inequalities. Okay, now, here we face a dilemma, or it would have been a dilemma if we weren't told a very important piece of information. We cannot multiply an inequality by a number that we don't know is positive or negative, because if it's negative, the inequality sign has to change direction. Now, x cubed, if x was able to be a negative number, then you cube a negative number, you get a negative number, and to get rid of this fraction, you have to multiply both sides by the x cubed. Now, doing that when we don't know whether x is positive or negative, or it could be negative, is a problem, because then it could mess up our whole answer. Okay, so what we would have had to do if we didn't have the piece of information which they told us where x is greater than 0, so x is definitely positive, so we don't really have to worry about this. If they had not told us that piece of information, then we would have to multiply by an even power of x, like x to the power 4. And then you would have 2x to the power 4 is greater than 72x, and then you're going to do some sort of factorizing and stuff and solving. But we don't have to worry about that, because we can say as x is greater than 0, therefore x cubed must also be greater than 0. Therefore, that means we can multiply by x cubed, the inequality. Okay, so you don't actually have to write that. I just want to explain that to you, because sometimes there's something kind of new in the P2 book where they give you inequalities to solve like this, and you don't know whether x is positive or negative. So you have to multiply by an even power of x, because even if x is negative and you raise it to an even power, it's going to become positive, because you're multiplying minus by minus an even number of times. But anyway, we don't have to worry about that in this question. We just multiply by x cubed. You got 2x cubed is greater than 72. Divide both sides by 2. You have x cubed is greater than 36. So we can say, therefore, x is greater than the cube root of 36. Not the square root, the cube root. Okay, don't get mixed up there. So we can say, therefore, f of x is increasing, okay, when x is greater than the cube root of 36. You could write it to 3SF if you want to, or you could leave it in this form. It's probably better to leave it in this form. There's no problem. It doesn't say, if it said exact values of x, then you would leave it like this. Right, now, then it says basically, so as I was mentioning, if you wrote the answer as x is greater than or equal to the cube root of 36, that's also acceptable. But I prefer, as I mentioned, this is my answer, because I feel that it's more kind of logical to say that it's increasing when the gradient is positive, when it's rising. When the gradient is negative, it's like, when the gradient is 0, it's kind of like, when the gradient is equal to 0, then it's kind of like flat. It's not increasing or decreasing. Okay, no problem. Next question, number 10, part B. It's saying show that the integral of 36 over x squared plus 2x minus 13 with respect to x between the limits of 2 and 9 is equal to 0. Okay, so for a question like this, you have to be very clear to show your steps, because they've already told you what it's equal to. So if you just write a whole heap of a whole mess here that doesn't make sense and you put equal 0, you're not going to get the marks. So you've got to make sure that you write everything clearly. So again, first things first, let's get this prepared to be integrated, which is exactly the same way you prepare something to get differentiated. You have to make sure the powers are written as numerators. So it's 36x to the power of minus 2 plus 2x minus 13. Whoops, where's that bracket come from? Minus 13 and with respect to x. So whenever you've got separate terms, always put in brackets and then with respect to x. Now, we haven't started integrating yet, so we keep this elongated S kind of shape at the beginning, the integral sign. But now, once you start integrating, you change that to a square bracket. Don't keep it as this sign once you've started to integrate, because it doesn't make sense. Because it's telling you integrate with that with respect to x. So now we must start integrating. Now, integration is the exact inverse of differentiating. So you do the opposite operations in the opposite order. So for differentiating, we multiplied by the power and then we took one from the power. So now what we're going to do is we're going to add 1 to the power. So it becomes minus 1, and then divide by the new power. So we don't multiply by the power and take 1 from the power, we do the opposite in the opposite order. So we add 1 to the power, and instead of multiplying, we divide by the new power. And now you're going to do the same thing here. We're going to, remember this is 2x to the power of 1 actually, we don't have to write that one. You add 1 to the power, so you're going to have 2x squared, and you divide by the new power, you get your 2, and you get minus 13. Now remember, this is, as we said, 13x to the power of 0. You can think about it like that. 13 is the same as this. So if you add 1 to the power, you have 13x to the power of 1 divided by 1, which gives you 13x. Okay, so you close your bracket and you now write the limits on the right side of those brackets. Now, we've got to substitute these values in. But before doing so, I'm going to just write this in a more friendly manner. This is like minus 36 over x. Now we can write it in the denominator. It makes it easy for us to substitute. The 2's cancelled here. So you've got plus x squared minus 13x. That looks a bit more friendly now to substitute the values in. So putting 9 inside this, I'm going to keep a squared bracket and open a new bracket. 9, that's minus 36 over 9, which is going to give me minus 4, plus 9 times 9. I'll just write 9 squared, which is 81. Minus 13 times 9. I'll just write that here so it's clear. And then I've got to take away from that what I get when I substitute 2 into this expression. So you're going to have minus 36 over 2 plus 2 squared, which is 4, minus 13 times 2, which is 26. I'll just write that there. So now we got here, close the main bracket, we got here minus 4 plus 81. You got minus 90, 90 plus 27 is minus 117. And you got minus, and you got now minus 18 plus 4 minus 26. Okay, so now let's see what that gives us. This is, let's have a look at this, is minus, so minus 117, minus 4 is minus 121. So you have minus 121 and plus 81. I think that's minus 40. Okay, let's just make sure in case we made a silly mistake. So you have minus 4 plus 81. Minus 117. Oops. Minus 4 plus 81. Minus. It's minus 117. What am I doing? Sorry. Yeah, minus 40. I was better without the calculator actually. Anyway, minus 40. So you've got to be careful when you use a calculator. Sometimes you press the wrong button. And then you got here. Let's see. That's going to give me minus 18 minus. So it's minus 18 minus 22, isn't it? Which is minus 40. Okay, that's minus 40. Again. All right. So does that give us 0? Yes, it does, because you've got minus 40 plus 40. Minus and minus gives you plus, which equals 0. So you've shown that this is equal to 0. I should put the equal signs here, really. Okay. All right. So basically, the reason why I've gone through the steps a bit more, in more detail, is because we already know the answer to the question is 0. Okay, so we have to show it clearly. That's all. So the examiner, I mean, if you write a lot of nonsense there, then the examiner might, not give you the marks if you can't see what you've done. Okay. Now, last part C of the question, it tells us the point P20 and the point Q60 lie on C. So I've just got a little, I've got a little kind of copy of the first page, so I don't have to keep switching. it says the point P is 2, 0. Oops. So there's a 2 here, and the point Q is 6, 0. There's a 6 there. All right. And they've told you that given that the integral between 6 and 2, so between these two, the integral of this function is equal to minus 8 between 6 and 2. So when you integrate a function between two limits, what you're actually doing is you find the area between the curve and the x-axis. That's what you're doing. So basically what they're telling us is that the area here, its numerical value is negative 8. Okay, the magnitude would be 8, but the numerical value, what you get when you put these limits and you integrate them into this, is going to be negative 8. So it says, given that the integral between 2 and 6 of that function is equal to negative 8, it says state the value of the integral of that same function between 6 and 9. Okay, so 9 would be somewhere over here. So let me make a vertical line. So basically what they're saying, they're asking us to do is to find the area, or to state what we think the area of this part must be. Now, if I know that the area of between 2 and 9 is 0, it means that these two areas must have cancelled each other out, because one is below the x-axis, it will give us a negative answer. The other part is above the x-axis, it will give us a positive answer. That's what's happened. The area here and the area here have cancelled out, so that must be positive 8. So this must equal 8. That's all you have to write. It says state the value. It's just your understanding of this particular concept, that when an area is below the x-axis, it's going to give you a negative value. The area between that is going to give you a negative value. And when it's above the x-axis, it gives you a positive value. If they had said to you, find the area between 2 and 9, then what you would have done is you would have taken the area between 2 and 6 and the area between 6 and 9, and you would have changed them both to positives and added them together. Because of course the area here is not 0. Okay, it's just that this magnitude of this is 8, the magnitude of that is 8, so the total area is actually 16. But the numerical value you get is negative 8. That's why when you find the integral between 2 and 9, they cancel each other out. So if this is negative 8 and the area of the whole thing is 0, this must be positive 8. Okay, so it just says state it. It's probably just worth 1 mark. And, there's not really any calculations involved. Then it says find the value of the constant k such that the integral between 2 and 6 of this function, but it's slightly different now. You've got the same thing in the beginning, but you've got plus k with respect to x is equal to 0. So basically now what we have to do is, I guess the easiest thing to do is just integrate this, which we already did up here. Actually, we did on the other page. Let's do it again. So you're going to integrate this, and when we integrated it, let me just get it from the other page. It was minus 36 over x plus x squared, and you're going to have a k there. You're going to have a k there. Let's have a look. Kx. So you're going to have minus 36 over x. This gives you minus 36 over x plus x squared, and you're going to have minus plus kx. We're looking at the wrong one. Plus kx. Okay, when you integrate k with respect to x, you're going to get kx. K is a constant. Between 6 and 2, that has to give us 0. So let's go ahead and solve. So this is the integrated version of that. Okay, and we're going to substitute 6 and 2 into there. So you have minus 36 over 6, which is, I'll just write it out. Minus 36 over 6 plus 6 squared plus 6k minus, and you're going to have 2, so it's minus 36 over 2 plus 2 squared plus 2k is equal to 0. So let me just make a bit more space here. So minus 36 over 6 is negative 6 plus 36 plus 6k. You're going to have a minus, and a minus is going to give you a plus. So you have plus 18. You have a minus, and a minus gives you a minus. That's going to be negative 4. And you're going to have minus 2k is equal to 0. So you have negative 36 plus 36, that's 30, plus 18 minus 4, that's plus 14. So you're going to have 44. And you're going to have plus 6k minus 2k is 4k equals 0. So you can say 4k is equal to 44. So k is equal to 44 divided by 4, which is, sorry, what did I do there? Be very careful. 4k is equal to minus 44, negative 44, because you have to subtract 44 from both sides. So k is equal to negative 44 over 4. So k is equal to negative 11. And there we have the answer, and we have finished paper 2 of June 2019. We've gone through all the questions. Thank you for watching. I hope you understood, and please read the description below to find the playlist where you'll find the other questions on this paper, and there's another link for playlist where you find other questions on the topic of calculus, integration, differentiation, whatever. And also you'll find a link to some of my kind of like index. You can say an index page is PDF kind of file. It leads you to a PDF file, and you can click on different topics, and it will give you all the questions collected together that I answered on those topics. And you also have links to different papers that I have answered. You'll get the links to the playlist for all of those from that document for P1, P2, P3, P4, S1, S2, and also for the IGCSE subjects, for those of you who know somebody who might be interested in that. Anyway, here we have the end of this paper. Thank you for watching, and see you soon.